Now we're going to graph absolute value inequalities. And there's just a little bit of adjustment you have to make because it's an inequality. Otherwise, it's going to be very, very much like graphing an absolute value function or equation. So here's our problem. Y is greater than or equal to the absolute value of x plus 2. Analysis is key. You see the absolute value, so you know it's going to make a V. Now, when you have an absolute value, the most important point is that vertex. And to find the vertex, you have to remember your rule that you memorized. To find the vertex, take what is inside the absolute value, whatever it is, and set that equal to 0. So I'm going to start off with x equals 0. Now a lot of times you're going to have something else in there like x plus 5 or 2x plus 3. But for now, all we have is an x. So I'm going to set it equal to 0, and I don't even have to solve. So I saved myself a step there. Now let's make an XY chart. And as usual, when we're doing absolute values, I like to put the vertex kind of in the center. So we're going to start with 0 for our x coordinate. Now to plot that point, I also need a y. So the vertex has two steps to it. I have to solve for x to get the x. Then I have to take this number, put it in here, and solve it to get y. So let's take y is greater than or equal to, put my x in here, 0 plus 2. The absolute value of 0 is 0. When you add that to 2, you get y is greater than or equal to 2. So here's my vertex, and I can go ahead and put it on here, 0 to the right or left and up 2. There's my vertex point. Now, to find the other sides, and you look in front of this, since it's positive, you know your V is going to open up. I need some points to the right and to the left of my vertex. So just pick some random points. I'll pick positive 2 and positive 4. And let me put these in order. Then on the other side, let's just go ahead with negative 2 and negative 4. Now a lot of times they're going to tell you to pick more points than this, so just pick some more numbers. That's all you got to do. This will be sufficient for us. Alright? Now I'm going to take each one of these x values that I just picked, and I'm going to plug it in here, and I'm going to solve it. And every time I solve it, I'm going to get a y value. So when I put 4 in for x, I've got y is greater than or equal to absolute value of 4 plus 2. The absolute value of 4 is 4, and 4 plus 2 is 6. Alright, my next one, positive 2. I've got the absolute value of 2 plus 2. The absolute value of 2 is 2. 2 plus 2 is 4. So there's my y. Okay? Now let's find these other two. When I fill in negative 2, I've got y greater than or equal to absolute value of negative 2 plus 2. The absolute value of negative 2 is 2. And 2 plus 2 is 4. And as with an equation, you should expect your numbers to start repeating. So let's plug in negative 4. And now I have y is greater than or equal to. Absolute value of negative 4 is 4. And 4 plus 2 is 6. And we're ready to graph. Now this is one thing that is different with an inequality than with an equation. If this is less than or equal to or greater than or equal to, you use solid lines on your graph. But if it's just less than or greater than, you're going to use a dotted line or a dashed line. So for this one, we're going to use a solid line. I want to point at positive 4, 1, 2, 3, 4, and up 6, which is here. And I want to point at over 2 and up 4, which is here. And there's the right side of my absolute value. Now at negative 2, and go to your origin. You're graphing from the origin every time, not your vertex. 1, 2, and up 4. And my other point is negative 4, positive 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. Now, like I said, if this had been just less than or greater than, I would have used dashed lines for my graph. Okay, now this is where it gets different because of this sign, you have an area. You're not finding one thing, you're finding an area. This graph divides your coordinate plane into two areas. There's the area inside your V and the area outside your V. So we have to decide which one do I need to shade. Well, we're just going to pick a point. Now it cannot be a point that is the vertex, and it cannot be a point that is directly on that line. If possible, I like to pick the 0, 0. And fortunately, this one is fair game for this because it's just out in the open. Now when you pick your point, you're going to plug it in up here. If this is 0, 0, I've got 0 for x and y. So I'm going to have 0 is greater than or equal to absolute value of 0 plus 2. And absolute value of 0 is 0, so I have 0 is greater than or equal to 2. Now that was this point right here. Is this a true statement? Is 0 greater than or equal to 2? No, it is not. So all of these points where that one was, they're not going to work. That's not my solution set. My solution set is the opposite area. If this was outside the V, I'm going to shade everything that is inside the V. Now if you want to check it, which is a good idea, let's just pick a point on the inside. That would be, let's see, 0 to the right or left and up 1, 2, 3, 4. So let's check the point 0, 4. Now remember, 0 is your x and 4 is your y. So I'm going to have 4 is greater than or equal to 0 plus 2. 4 is greater than or equal to 2. Is 4 greater than 2? Yeah. So that verifies that it's the set of numbers inside the V that make this true. Okay? Let's look at one more. Okay, here's this another one. Y is less than absolute value of 4x plus 1 minus 3. So yes, we analyze, we see the absolute value, we know we're looking at a V. It is positive, so we also know the V is going to open up. And we know the most important point we need is that vertex. So we recall, to find a vertex, step 1 is to take whatever is inside the absolute value and set that equal to 0 and solve. So I'm going to do 4x plus 1 equals 0, and I'm just going to solve it. I'm going to subtract 1 from each side, so now I have 4x is equal to negative 1, and then divide by 4, so I have x is equal to negative 1/4. Now I'm going to make my little xy chart over here. This becomes the x coordinate of my vertex, and I'm going to put that kind of in the middle. All right. Now, in order to find the y coordinate, I'm going to take this number and go back up here and fill it in for what? For x. So let's take the whole thing this time. Now to find the x coordinate, all you needed was what was in here. But to find the y coordinate, I need the whole thing with 1/4 filled in, just like this. Now, 4 times negative 1/4 is negative 1. And negative 1 plus 1 is 0. The absolute value of 0 is 0. And 0 minus 3 is negative 3. So that's going to be the point of my vertex. Let's go ahead and graph it over here. Now, we're not going to stress out over that negative 1/4. We're just going to get close. So go to the left 1/4 and then down 3. 1, 2, 3. That's about right there. Okay? Now, I need some points on either side of this. So just pick some numbers. How about 1 and 3? And those are going to be your x coordinates. Now let's go to the left. How about negative 1, negative 3? And we are going to put these in for x, all 4 of them, and we're going to solve them, and that's going to give us 4 y coordinates, and then we can plot our graph. So for the first one, y is less than absolute value of 4 times 1 plus 1 minus 3. So 4 times 1 is 4. 4 plus 1 is 5, and the absolute value of 5 is 5, and 5 minus 3 is 2. All right, let's do 3 now. I've got absolute value of 4 times 3 plus 1 minus 3. 4 times 3 is 12, and 12 plus 1 is 13. And the absolute value of 13 is 13, and 13 minus 3 is 10. Okay? Now let's find the other side of our graph by filling in these other x's. First, a negative 1. So I'm going to have 4 times negative 1 plus 1 minus 3. 4 times negative 1 is negative 4. Negative 4 plus 1 is negative 3. And the absolute value of negative 3 is 3. 3 minus 3 is 0. And then last one, I'm going to fill in this negative 3. So I've got 4 times negative 3 plus 1 minus 3. 4 times negative 3 is negative 12. Negative 12 plus 1 is negative 11. And the absolute value of negative 11 is 11 minus 3. And 11 minus 3 is 8. So we're ready to graph this. Now we do need to pay attention. Since this is a less than, we are going to use a dashed line, not a solid line. So let's graph our points first. We've got 1, 2. So I'm going to go over 1, up 2. Then we've got 3, 10. So I'm going to go over 3 and up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I am going to make a dashed line and put my arrow on the end. Okay? Now let's graph the other half. Negative 1 and 0. Now remember, you're graphing from the origin, not the vertex. So there's my first point. My second point is at negative 3, positive 8. So 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And then make a dashed line with arrows at the end. Okay, it's a little bit crooked, but we can see what we're doing. All right. Now, I need to determine whether my solution set is on the outside of the V or the inside of the V. So I'm just going to pick a point. I see my favorite point, 0, 0, is available because it is not the vertex and the lines don't go straight through that point. It's on the inside of the V. So I'm going to take the point 0, 0. And I'm going to plug it in, and if it makes a true statement, then I'm going to shade the area that contains that point. So here's my y. I've got 0 is less than absolute value of 4 times 0 plus 1. And once again, be careful. You know, I picked a point that has both numbers the same. So my x and my y are both the same. But if you choose something different, make sure you plug the second number in for your y. Alright, 0 is less than. 4 times 0 is 0. 0 plus 1 is 1. And the absolute value of 1 is 1. 1 minus 3 is negative 2. Now, is 0 less than negative 2? No, it is not. So I do not want the portion that's inside the V. I'm going to shade everything that is outside the V. Just like that. Okay? So all my solution sets are on the part that's outside the V. Okay? Key to this is practice, practice, practice. So find some practice problems and go to work. See you next time. Bye.